My topic was to draw all the products for an electrophilic addition to conjugated double bonds and to label the major and minor and kinetic and thermodynamic products. A molecule is conjugated when it has alternating single and double bonds, so alternating sigma and pi bonds. When compounds are conjugated, they are more stable. So as you can see in this molecule, it's conjugated. It has a double bond, a single bond, a double bond, a single bond, and another double bond. Electrophilic addition to a conjugated molecule forms two products, a 1,2 product and a 1,4 product. These products can also be classified as kinetic and thermodynamic products. When conducted in mild conditions, such as low energy and in the cold, with no heat added, the major product will be the kinetic product. However, if a reaction occurs in vigorous conditions, such as high temperatures, the major product will be the thermodynamic product. In this electrophilic addition, we're going to use 1,3-butadiene and add hydrochloric acid. The reaction will take place in negative 55 degrees Celsius. Reaction, the double bond will act as a nucleophile and attack the hydrogen, which will then bounce those electrons to the chlorine. This will form a carbocation with the hydrogen attached to the first carbon. This carbocation can undergo resonance with a shift from this double bond to this spot, which will form this carbocation with a positive charge on that carbon. Now, each of these carbocations can react with the chlorine ion we formed before. Starting with the carbocation we formed in the first step, the electrons from the chlorine will attack the positively charged carbon to form this molecule, which would be considered the 1,2 product because the hydrogen added to the first carbon and the chlorine added to the second carbon. Using the second carbocation that we got from resonance, the same chlorine ion can be used and the electrons from that chlorine ion will attack the positively charged carbon, like we did before, to form this product, which would be considered the 1,4 product, as the hydrogen added to the first carbon and the chlorine added to the fourth carbon. The next step will be to figure out the thermodynamic and the kinetic product, as well as the major and the minor product. If we look at the energy diagram for the formation of both of these molecules, we can see that the activation energy is the same initially until the first carbocation is formed. After that, the 1,2 product has a smaller activation energy, and the 1,4 product has a larger activation energy. However, the 1,4 product is more stable than the 1,2 product. To determine the kinetic product, we look at the product with the lower activation energy. In this case, this would be the 1,2 product. So we can say that the 1,2 product is the kinetic product. Now, to figure out the thermodynamic product, we look at which product is more stable. And in this case, it's the 1,4 product because the pi bond is di-substituted in the 1,4 product, while the pi bond is mono-substituted in the 1,2 product. So we can say that the 1,4 product is the thermodynamic product. Now we figure out which product is the major and which is the minor. So as we said before, the kinetic product will be the major product if there are mild conditions, such as a cold temperature. So in this reaction, the temperature was negative 55 degrees Celsius, meaning the kinetic product was the major product, and the thermodynamic product would be the minor product. Now, if we repeat the same reaction using the same reactants but under different conditions, so in this case with heat added at 78 degrees Celsius, we would get the same two products. 1,2 product and the 1,4 product, the 1,2 product will still be the kinetic product, and the 1,4 product will still be the thermodynamic product. However, in this case, as we said before, when heat is added to this reaction, the major product is the thermodynamic product. So in this reaction, the major product would be the 1,4 product, and the 1,2 product would be the minor product. Now that we know how to perform an electrophilic addition reaction, we can perform the same reaction on 1,3-cyclohexadiene using dibromine and 62 degrees Celsius conditions, which means heat is being added. Just like in the last example, the pi bond will be used as a nucleophile and will attack bromine, which will then give the rest of the electrons to the other bromine. This will form a carbocation intermediate with a bromine added to it. Again, this carbocation can undergo resonance when you take the electrons from this pi bond and move them here to form this carbocation intermediate. Then, similar to like we did before, we will use both of these carbocation intermediates and react them with the bromine ion that remains. The electrons from the bromine ion will attack the positively charged carbon to form the 1,2 product. When we react the other carbocation with the bromine ion, we will use the same electrons and again attack the positively charged carbon, and we will form the 1,4 product. Now we need to determine the kinetic and the thermodynamic product. When we think back to what we did before, we determined that the kinetic product would be that would have the lowest activation energy. So most of the time, it would mean that it would be the carbocation that we got from the original reaction with no rearrangement. In this case, the 1,2 product would be the kinetic product. Now we think of the thermodynamic product, which would be that with the most stability. In this case, the 1,4 product would be the thermodynamic product. Now we think back one more time to determine the major and the minor product. And we remember that we said that the major product would be the thermodynamic product when heat is added. So we noticed that the reaction occurred at 62 degrees Celsius, which means heat was added, making the thermodynamic product the major product, and the kinetic product the minor product. I hope this video was helpful, and if you guys have any questions or comments, please let me know.